Okay, so this can be the second part of the factoring strategy. So remember, we're gonna utilize this flowchart again. Now let's just go directly into some examples. Now suppose we want to factor. All right, suppose we look at this problem. Let's say I want to factor 3x to the fourth times y plus 6x cubed times y minus 72x squared y. All right, suppose I wanted to factor this. All right, so the first thing you look for is a common factor. Now, other than 1, is there a GCF other than 1? In this case, there is, because you first of all, you notice there's an x in every term and there's a y in every term. All right, now look at the GCF of the coefficients, 3, 6, and 72. We know that 3 goes into 72. Now, I should have said this coefficient is a negative 72. This coefficient is negative 72. But the GCF is of all three will be 3. So the GCF of all three coefficients is 3. All right, for the variables, I have x in all of them, so I'm going to need an x here. So remember, you take the one with the smallest exponent, so x to the fourth, x cubed, x squared. So I'm going to take out x squared. And then there's y in all of them. They're all raised to the same power, so since the power is 1, I'm just going to say y. So there's your GCF. All right, so you're going to factor out the GCF. So I get 3x squared times y times, all right, so 3x squared y times what is 3x to the fourth y. So I'm going to have to say x squared, because x squared times x squared is x to the fourth, and then 3 times y times 1 is 3y. So I get this times this is this. Plus 3 times 2 is 6. X squared times x is x cubed. Y times 1 is y, but we don't put the 1, we just leave it as 2x. Okay, minus 3 times what's 72? So that's going to be, if you don't remember, just use your calculator. Say 72 divided by 3, and I get 24. So it's going to be 24. And x squared times 1 is x squared. Y times 1 is y. We just leave it off because 24 times 1 is just 24. All right? Okay, so that's where I'm at. Okay, so now once you factor out the GCF, this is where we are. Once you factor out the GCF, cover up the GCF for right now, and ask yourself how many terms do you see here in this parentheses? Well, there are 3. So I'm right here now. There are 3 terms. So then we go directly to factoring it as 2 binomials. So I'm going to go off to the side right here. So far I know I'm going to get this. I'm going to get 3x squared y times 2 binomials. All right, and whatever that is, that will be your answer. All right, so we got to figure out what this is though. So x squared plus 2x minus 24. The fact that the squared term is 1 is going to make this easy to factor. All right, so we're going to do trial and error using the idea of FOIL. Okay, the first times the first, x times x is x squared, so that's good. All right, remember the last sign's negative, so that means that both signs in here are going to be different. And remember the outer and the inner, one's going to be positive, one's going to be negative, and when I add them up, I got to get this 2x. But in particular, it's positive, so that means the larger of these will have to be positive. So let's think about negative. Well, let's think about 24. I know that this is the last term is negative, but let's just look at the absolute value for right now. All right, so the absolute value of negative 24 is 24. All right, if I put a 4 and a 3 here, just to play around, if I put a 4 and a 3 here, I know that's not going to work. Right away, you know it's not going to work because that's a 3x, that's a 4x, and I know the larger of these has to be this middle sign. That means this is negative, but that's not going to work because 4x and then negative 3x is x. I wanted 2. All right, so I knew that wasn't going to work. So what you want to try next is instead of 4 and 3, try 6 and 4. I wouldn't do 12 and 2 either, and I wouldn't do 24 and 1 because this needs to be a 2. So 6 and 4. Check yourself though before you go on. The outer is 4x, the inner is 6x. The larger of these numbers, 6, 6, so the 6x here will be positive, so that means 4x has to be negative. And when I add them up, I will get this 2x that I need. But I just got to go in there and fix the terms, fix the signs. So since I want 4x to be negative, that means that this 4 here, the outer, has to be negative. I want the inner to be positive. In order for that to happen, this term right here has to be positive. All right, so this right here, factored, is this. So this is this. So now this goes here. So I get 3x squared y, don't forget your GCF as part of the answer, times x plus 6 times x minus 4. All right. Number 2. Suppose we had 12x cubed y plus 243 xy. Before I go on, just remember that the last thing in all of these cases was that you got to check each factor. Can you factor any further? So in other words, see this factor right here, x plus 6? Can you factor it any further? What's your GCF? Well, it's just a binomial with x being raised to the first power. So, and the GCF is 1. Here, same thing. So you can't factor these two any further, so you're done. All right, over here, look for GCF. The GCF here will be, well, in terms of the variables, you know you're going to have an x, at least one x, and you know you're going to have at least one y. Okay? Now, let's go with the 12 and the 3. So, I know that 3 will go into both of those. You can check this. 243 divided by 3, you get 81. But check the other factors just to be on the safe side. So another factor of 12 is 4. All right, and you know that 4 won't go into 243 because the last digit is odd, so that's not going to happen since a factor of 4 is 2. 6 won't occur either for that reason, that the last digit is 3. I mean, you can check it. Last digit is 3, so 243 divided by 6 is 40.5. All right, and check yourself. If you do 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5, 6 times 6, the last digit is always going to be an even number. Here, the last digit is odd. Okay, and then 12. Again, 12 is even, so 12 times 1, 12 times 2, 12 times 3, 12 times 4. When you multiply that, the last digit is always going to be even, and this is odd. All right, so the GCF here has to be 3. And so for the x's, I'm going to have to use x to the first, and the y has to be y. Okay, so there's your GCF. So 3xy. So I'm going to factor it out, and I get, so 3xy times 4x squared. 3x squared times 4x squared is this. 3 times 4 is 12. X times x squared is x cubed, and I have this y that I took out. Plus, and then 243 divided by 3, you get 81. Plus 81. And I already took out the x and the y. So 3xy times 81 is 243xy. All right, so that's where I'm at. All right. So then you go over here, and again, you cover the GCF, and you ask yourself, how many terms are there? There are 2 terms. And there's a plus sign in the middle. And so you check and see, well, is this the difference of 2 cubes? It can't be the difference because it's a plus sign. It's a sum. So is it a sum of 2 cubes then? The answer is no, because this is x squared. So remember, this turns out to be the sum of 2 squares. So the sum of 2 squares is 4x squared plus 81. If I fill this in right here, that's the sum of 2 squares because that's a 2x and that's a 9. And remember, in a previous lesson, we talked about the fact that the sum of 2 squares cannot be factored any further. Right? So when I did this, you recheck each factor. Can it be factored further? So it can't. So that's your answer. So the answer is just 3xy times 4x squared plus 81. Now don't say, when you get to this point, You know that 4x squared plus 81 can be factored, so that means that this right here is prime. But don't say the answer is prime, because remember you want to factor, and I did factor. I factored out the GCF, but that's all I could do. So there's your answer. All right, so don't say prime here. Don't say that this right here, number 2, is prime. It's not, because we factor out a GCF. This right here is prime, but this is not. Okay? All right, number 3. Suppose we had 4x squared minus 8xy minus 3x plus 6y. So 4x squared minus 8xy minus 3x plus 6y. All right. So the GCF here is 1. Okay. So I'll go directly to how many terms are there. Well, there are 4 terms. I'm going to factor by grouping. So I'm going to group the first 2. I'm going to group the last 2. So from the first group, I can factor out a 4x. And so 4x times x is 4x squared minus 4 times 2y. So, I'm sorry, 4x times 2y is 8xy. All right, so that's what this becomes. Over here, remember, you got to factor out the negative factor. So it'll be a negative 3. All right, so when I factor out negative 3 times what is a negative 3x? The answer is x. Negative times a negative is a positive. So a negative 3 times a negative 2y, negative 3 times negative 2y is a positive 6y. And if you look at this, these two groups, they have an x minus 2y as a common factor, so you factor it out. So I get x minus 2y times 4x minus 3. And so that's your answer there. Okay, number 4. All right, suppose we had 6x squared plus 18xy plus 12y squared. All right. So again, GCF is 6. So I'm going to factor out a 6. So I get 6 times x squared plus 6 times 3 is 18. So I get 3xy. 6 times 2 is 12. So I get 2y squared. Okay? Now, remember, if you're still here, you got to ask yourself how many terms are inside this parentheses. So there are 3 terms. There are 3 terms. All right? And so if we got to check and see if this can be factored in further. So there are 3 terms. So that's supposed to be a 2y squared. All right, so we go directly to 2 binomials. We use FOIL. Now this is not going to be that bad because this coefficient here is 1. So x times x is x squared, so that's a good thing. 2 is prime. This coefficient here is prime, so that's going to be easy as well. The last sign is positive, so that means both of these signs are going to be the same. It'll be this middle sign. So both will be plus plus. And then again, since 2 is prime, the only possibility is 2 times 1. So I'm going to say 2y. Don't forget the y, though, because this is y squared. It's not just 2. It is 2y times y. Now, don't say 1y. I mean, you can, but we tend to leave that off. It's understood to be a y, and it makes it look better. So it's easy to see x plus y than saying x plus 1y. All right, now check yourself, though, before you go on. FYL. Okay, the F works because x times x is x squared. The last is okay. 2y times y is positive 2y squared. Now check the outer. The outer is xy. The inner is 2xy. When I add them up, I get 3xy. And that's what you wanted. So this right here can be factored as these 2 binomials. But then remember, though, the GCF was 6. I'm trying to factor this. The GCF was 6. So it's going to be 6 times these 2 binomials. X plus 2y times x plus y. All right, number 5. Suppose we had xy squared minus 4x plus 3y squared minus 12. All right. Okay. So again, the GCF here is 1. I do see 4 terms. So I'm going to factor by grouping. So I'm going to group the first 2, group the last 2. And so when I group the first 2, I can factor out an x. And so I get x times y squared minus 4. X times y squared is xy squared. X times a negative 4 is a negative 4x. Over here, I can factor out a positive 3. And I get y squared minus 4 again. Okay? So these two groups, they have a y squared minus 4 in common, so I factor it out to get y squared minus 4 times, and if I factor out the y squared minus 4, I'm left with x. If I factor out the y squared minus 4, I'm left with positive 3, so plus 3. Okay, but you remember, down here it says check each factor can be factored again. So if I look at x plus 3, that factor, I can't do anything with it because the GCF is 1. But if I look at this, remember y squared minus 4, y squared minus 4 is the difference of 2 squares. That's the difference of 2 squares. All right, so that means that difference of 2 squares. That means that y squared is a perfect square. I can write it as y squared. 4 is a perfect square. I can write it as 2. So then this becomes the difference of 2 squares, remember, is in this case will be y minus 2 times y plus 2. So that's how you factor y squared minus 4. And so that right here, see this right here, that is this. So I get y minus 2, y plus 2, and then bring down the x plus 3. And there's your answer. So this right here, remember the previous lesson, we stopped here because these could be factored any further. But this one can now because that's the difference of 2 squares. So make sure you factor the difference of 2 squares. So instead of having these 2 factors, I'm going to have these 3 factors as my answer. And I can't factor this any further. GCF here is 1, GCF here is 1, GCF here is 1. Okay? All right, and then the final one for this group will be this one. So let's go to number 6. All right, suppose we had this. Let's suppose we had x cubed y cubed plus 8z cubed. X cubed y cubed plus 8z cubed. Okay, so the GCF here is 1. GCF is 1. I have two terms. And notice not a difference because this is a sum. So I want to check and see, is this the sum of 2 cubes? And it is. You see the cubes here? So it is because you can fill in. Always check this. You can fill in these parentheses. It turns out that this right here, this is a perfect cube because I can multiply xy by itself 3 times and I'll get this. X times x times x, x cubed. Y times y times y is y cubed. Over here, so what times itself 3 times is 8z cubed. The answer is 2z. So check yourself. 2z times 2z times 2z. 2 times 2 times 2 is 8. Z times z times z is z cubed. Okay? So this is the sum of 2 cubes. This right here is the sum of 2 cubes. So remember how you factor the sum of 2 cubes. So the formula, if you go back to that sheet, the formula sheet, the sum of 2 cubes, I'm going to go ahead and use F and L, will be F plus L times F squared minus, when we change the sign, FL plus L squared. Okay? So it's very similar to the difference of 2 cubes. So the difference of 2 cubes, remember, and let me go ahead and write it right here. So the difference of 2 cubes was F minus L times F squared plus FL plus L squared. So remember, the only difference between these, the order of the letters are in the same place, is just these 2 signs right here. All right? Okay, so this is your F, this is your L. So the sum of two cubes, the binomial, remember it's a binomial, this one's a trinomial. The binomial is F plus L, so F plus L. So I get xy in parentheses plus 2z times this trinomial. All right, so here's how I do the trinomial. Okay, so f squared means f times f, if you need to write it out. F here is xy, so that means xy times xy. So that becomes x times x is x squared, y times y is y squared. All right, so you got to write it like this, you got to simplify this. So I get x squared, y squared, minus, then I have to say f times L. Well, f is xy, L is 2z, so this becomes 2xyz. 2xyz, so minus 2xyz. And then L squared means L times L. Well, L is 2z, so that means 2z times 2z, so 2 times 2 is 4, z times z, z squared. So that goes here, plus 4z squared. And then that would be your answer. Okay, so that's going to conclude this portion.